All right, so today we are going to be talking about identifying conic sections. So we can identify conic sections. We're going to write some of them in standard form, and then we're also going to just identify them from their equations. We can also graph them, obviously. So here are the different conic sections that we dealt with this chapter. So let's start with the easy one, the parabola. Notice what happens with the parabola. We have x squared, but no y squared, or x and y squared. It's missing a squared. So we're going to be looking at the squareds, the x squareds and the y squareds, to see which one it is. If we're missing an x or a y squared, it's a parabola. And to go ahead and put that in standard form, we're going to get the one by itself and then move everything else to the other side and complete the square over there. But if you're missing something, it is most definitely a parabola. If it's a minus in between the two squareds, then it's a hyperbola. X minus y, of course, is the horizontal one. The y minus x is the vertical one. But that's a parabola. If it's a plus, it's either an ellipse or a circle. How do we tell the difference between an ellipse and a circle? We look at their coefficients, the numbers in front. If they're the same, it's a circle. If they're different, it's an ellipse. All right, let's look at a couple. So let's look at this one. We have an x squared and a y squared. So that rules out a parabola. We're going to need to move this over. So to write it in standard form, notice I move it over here. And now I'm looking at those two coefficients in front, since it's a plus. Since it's a plus, it's not a hyperbola. We know that we have both of them, so not a parabola. Now I'm looking at 2 and 1. Those are different. This will be an ellipse. So how do we finish making an ellipse? We divide by 18. 2 divided by 2 with 18 is 9, and then just 18 here. So to graph this, we have a point 0, 0. So we're at the origin. We're going to go left and right 3. Remember the square root of this, and up and down the square root of 18, which is like 4.2. So center 0, 0, left and right 3 dots there, up and down 4.2, down 4.2, and of course they make a pretty good ellipse, much better than what I make on my paper. All right, what about this one? We have an x squared and a y squared. It's not a parabola, and it's a plus, so it's not a hyperbola. The numbers in front, the coefficients, they're the same, so it is most definitely a circle, so we're not talking about this one here. All right, well, which one of these is it? If I was to start completing the square with the x squared, I'm going to take this minus 6 and divide it by 2, so it's a minus 3. The one with the minus 3 is this a value here. I don't even have to solve the rest of it. This one's a y squared and an x squared, but notice in between it is a minus. If it's a minus, it has to be a hyperbola. We knew it wasn't a parabola because I had both of them, but because of the minus, it has to be a hyperbola, and this is an up and down hyperbola. Here we have 2x squared plus 2y. Notice again, I'm just not worried about completing the square right now. If I have to write it in standard form, I would go ahead and do that, but right now I don't have to. So I'm just looking at the x squared and the y squared, and then I'm looking, I've got no parabola, I've got no hyperbola, I've got both of them, so the parabola's out, no minus for hyperbola, so it's either circle or ellipse, and those two numbers are the same, so that's going to create a circle. So here, we're missing the x squared. So if we're missing the x squared, it's a parabola. How would I put this in standard form? I'd move everything over to the other side minus this x, and I would then divide by the 2 and start solving it that way. What about this one? We have a y squared minus an x squared. Got them both, so parabola's out, but because of the minus, it's a hyperbola. Here, x squared and y squared, parabola's out, it's a plus, so no hyperbola. Looking at the numbers, we have 3 and 1, so it's an ellipse. Missing the x squared. parabola. That's what I have for you today.